Alright, today we're going to be talking about summation notation in series. Alright, summation notation, I can even speak. Summation comes from the words sum, so we're going to be adding stuff. The definition of this is the sum of the first n terms, so whatever it goes to, and it's represented by the following. So I have this Greek symbol, sigma, and at the bottom I have I equal 1, so that basically tells you where you're starting, and then at the top is n, so that tells me where I'm ending. So a to the I. Okay, so that gives you whatever your function is. Okay, so this is, we take a1 and we add it to a2 and we add it to a3 and we keep adding until we get to the however many terms n is. Alright, so where I is the index, n is the upper limit, and 1 is the lower limit. So whatever I equals, that's your lower limit. Okay, so let's look at example 1. I have n equal, I equal 1, 5, and then I have 3i. Okay, this tells me I have 5 terms. Alright, so to figure these out, I'm going to have 3 times 1 plus 3 times 2 plus 3 times 3 plus 3 times 4 plus 3 times 5. Okay, so I go from 1 to 5. That's what my index tells me. Okay, and I plug it into this equation right here. So I'm going to take these and I'm going to add them. So 3 plus 6 plus 9 plus 12 plus 15. Well, 3 plus 6 is 9, 9 plus 9 is 18, plus 12 is 40, plus, whoa, okay, just kidding, that's 30, plus 15 is 45. So this would be your sum of this system. Okay, let's look at another one. So I have 6, I have k equals 3, and then my equation is 1 plus k squared. So this letter needs to match whatever one's in your equation. So I'm going to go from 3 to 6. So that's where I'm starting with. I'm starting with 3. So I have 1 plus 3 squared plus 1 plus 4 squared plus 1 plus 5 squared plus 1 plus 6 squared. Okay, from here I have 9 squared or 9 plus 1, so that's 10. 16 plus 1, 17. 25 plus 1, 26. 36 plus 1, 37. Okay, if I add these together, I get 90. So that would be the sum of this equation. Okay, let's look at another example. I'm given I is 0, so that's where I'm starting, to 8. Okay, and then I have 1 over I factorial. Okay, the exclamation point, remember from yesterday, is factorial. So I'm going to have 1 over 0 factorial plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial plus, and I have to go all the way to 8. I'm running out of room. Okay, so there's this. Now, if I keep going here, this is 1, because 0 factorial is 1, so that's 1 plus 1 over, that's 1 again, plus 1 over 2, plus 1 over 6, because 3 factorial is 6, plus 1 over 24, plus 24 times 5, 120, plus 120 times 6 is 720, plus 1 over 50, 40, plus, I'm going to have to write this one down here, 40, 320. Okay, so If I added all these up in the calculator, yes, I know it's a lot of writing, we get that this equals about 2.71828, which is about E, if you remember when we did that. If you're interested in looking at properties or whatever, you can look at page 647. Okay, part B, series. So, the definition is the sum of the first n terms are finite sums or partial sums. Okay, this would be like if I had what we talked about earlier. Okay, it's finite because you're given explicit beginning and end points. Okay, an infinite sum is the sum of all terms of an infinite sequence. So this would be like if I started from 1, but I went to infinity. Okay, so your series, your sequence never stopped. Okay, I'm going to flip this over so we can look at an example. Alright, so I have from 1 to infinity, 3 over 10 to the I. Okay, first I want to find the third partial sum. So that means I want to go to the third term and figure out the sum there. And then I want to find the actual sum. Okay, so if we look at A, the third partial sum, I'm going to have from 1 to 3 now. Okay, still the same equation. So this is going to equal 3 over 10 plus 3 over 10 squared plus 3 over 10 cubed. Okay, when we do this, we get 0.3 plus 0.03 plus 0.003. Okay, when I add all those up, I get 0.33. Alright, now, what is this approximately? Okay, so on this, what do you think is going to happen? If you keep adding, the number keeps getting smaller and smaller and smaller. So 10 to the 4th would be 0.0003. Okay, well, if I kept adding, it would just keep adding 3's on the end. So what is 0.3333 repeating? It's about 1/3. So that would be your sum. That would be your infinite sum. Okay, are there any questions? If there are, please come see me in tutorials. Your assignment for this lesson is A3, page 650, numbers 73 through 80, and 99 and 100. Alright, please let me know if you have any questions, and good luck.